I'm going to go ahead and just start introducing our presenters. There's Chuck Powell, Nick Smilovsky, myself, Kasey Green, and Joseph Wagner. And this is a review and a recap of the AJIC UAS fly-in virtual event. Uh, Chuck, let me tell you a little bit about Chuck. Chuck is the Aero Data Acquisition Group Manager and SUAS pilot for Westland Resources. He specializes in collecting both mapping and vegetation data with fixed wing and multi-rotor aircraft. He also conducts indoctrination training for new pilots and refresher training for experienced pilots. Nick, Dr. Smilovsky, I always mutilate his last name, but I'll call him Dr. Nick, teaches at ASU, Arizona State University, in both landscape architecture and graphic sciences and urban planning. Dr. S focuses teaching on and research on innovative geospatial technology, including unmanned aerial systems and augmented reality. Additionally, he is a geographic information systems professional, certified arborist, and FAA Part 107 certified pilot. And myself, I'm currently a GIS and analyst for the State Land Department, serving as the data curator for AVGO. Before I started with ASLD, I worked as a GIS technician at the Department of Water Resources for Arizona, where I co-developed the SUAS surveying program for the Little Colorado River watershed hydrographic survey report, and that was fun. And also last, Joe Wagner is currently the mapping, surveying, and CAD manager for the flood control district of Maricopa County. Joe has a 30-year background in photographic mapping and LiDAR photographic mapping and LiDAR industry. Joe started the SUAS program for the district 4 years ago and is the drone program manager. The flood control district currently has 8 FAA Part 107 remote pilots. And so we're going to begin with Nick.
Right. Thank you, Kasey, for the generous words. Kasey, you can call me Slimo, Schleimo, Smilo, Shalotsky's Deli. It's okay. My wife, we've been together 9 years, and she's still having problems pronouncing her last name. So I appreciate the kind words and the intro, and thank you, everybody, for coming and participating in this presentation about UAVs. I see some familiar faces out there. It's good to see everybody, and thank you for all our panelists. As Kasey mentioned, this presentation is actually more of a recap about a program that we did over the summer. And so Jenna, who you may be very familiar with, the Deputy State Cartographer, as part of a subgroup of AJIC, we have a UAV group. And in that UAV group, we had a fly-in event, which was originally planned to be in the flesh. Pre-COVID, we were going to go out and have like a real fun time and fly drones and go do best management practices. But due to circumstances in 2020, we decided to make the event a 2-part series and it be all virtual. The first part of the series happened in June 30th. And the second part was on July 22nd. So there was about a month gap in between the two presentations. The first part of the 2-part event, for the first 2 hours, what we did is we reviewed the site, which we're going to do again today, Cave Creek Dam, and the purpose of why we were using innovative drone technology to map this. We discussed mission planning, data collection, best management practices, all of the basics, that kind of ground level that a new UAV pilot would need to know to jump into the industry. The second part of the 2-part event was after we had looked at the site, we had talked about different software and practices, and we got to see all kinds of great data provided to us. The second part of it was let me pause for just a second. What was really neat, not only did we just hypothetically and theoretically speak about all these things, we actually provided to anybody that was interested the data, the raw data collected by the drones with the GCPs and everything. And so you were able to go and download these data. We also gave a list of processing software and a little bit of explanations on each, and we encouraged users and people participating to go out and process these data so that we could have a panel discussion looking at how everybody looked at these data. And so at the end of this presentation, we're going to get the panelists all up. We're going to kind of review, and Kasey's going to ask us some questions and lead us through a discussion. But what was really neat was, and this is the first event I've been involved with, we all got the same data. We all got to do our special little tricks to it. And then we were able to come back to the table and collaborate and see how it went. So at the second part, we discussed processing, more best practices. Again, we talked more about photogrammetry software, compared the different types of deliverables, right? Because there's orthometric photos, there's point clouds, there's derivative deliverables like contour lines, assets, three-dimensional modeling. And then we kind of concluded with a discussion on the drones and the future. It was pretty cool. I believe, and I could be wrong, I want to say there was about 70 or so plus or minus participants. So a lot of participation, especially in the dead of summer. So it was great. So let's talk about Cave Creek Dam. So what was this place we were talking about? Cave Creek Dam, multi-arc concrete dam located near Cave Creek, Arizona. So if you are an Arizona native, you know Cave Creek's on the north side of kind of the greater Phoenix area, the valley area. If you're familiar with this area, it is sort of on the foothills of the mountains. You also have a lot of subsidence happening up there, so you have uplift and ground deformation. So there's a lot of control out there. And so this site is actively monitored. And so, actually, hey, Jim, by chance, I think you're unmuted. Any chance you can mute yourself, sir? I hear some feedback. So this dam was originally built in 1923. Primary dam preventing flooding in North Phoenix from 1923 to 1979. It was eventually replaced down the road. It is, importantly, a Maricopa County Flood Control District project. Its height is about 45 feet, and it's about 1,600 feet long. And you can see here's a picture of it. It's not a very normal shaped object, right? And so one of the things we want to be very cognizant about is how would you properly map something as interesting and off normal as this, right? It's just not a big square. And so this is the site that we had collected data. I only have a couple more slides. I'm going to pass the mic here, but know that these data were collected, and when they were collected, there was ground control used. So we didn't just fly autonomously. The project was collected with high accuracy ground control. So across the site, and you can see the small snippet there, each of those triangles are control. And so one of the things we discussed with the group was how do you properly lay out control? And how do you find the correct distance between the control, perhaps making them equidistance, finding high and low spots, making sure that you have control that'll help tie in the horizontal and the vertical. And you can see there that there was plenty of control out there to help geodetically adjust these data. So again, we wanted to make these data as real world as possible. We didn't want to do anything in the virtual kind of cloud form, or not cloud, but vortex format, right? Like this is real world. We want to use the drone to match measurements that you would say get using a GPS on the ground. And so again, we discussed why we picked these control and the importance of using control for drones if you want to collect high accuracy topography and 3D modeling data. If you are only using a drone without control, or you're using a drone that is not RTK enabled, so survey grade drone, just be very cognizant that your data potentially could have some errors. We get bowling effects, all kinds of different things that you really need to use control if you're going to be using drones in a professional sense to collect data. All right, so let me see here real quick. Chuck, I think this is a good point. If you don't mind, I would love to pass the mic over to you to talk a little bit about mission planning, um, and some of the different types of ways that the drone can do nadir flights, oblique flights. If you wouldn't mind, maybe talk a little bit about mission planning, maybe some of the software out there we discussed. If you could talk through speed and altitude overlap, that would be great.
So there's multitude of software for mission planning. Some of the more popular ones, Drone Deploy, Pix4D, DJI Go, and there's drone-specific ones. For one of my aircraft is SensaFly EB. We use eMotion software that is the only software that works with that aircraft. So when you're planning your mission, the speed, altitude, image overlap is based on project specific. So what is your end product you need to deliver for this project? It goes into all the aspects, all the parameters fit in with that end goal of that end product. The first thing we always need to check is airspace. So I can't reinforce this enough. To know before you fly, the great FAA thing. So make sure you're legal to fly. Make sure there's no temporary flight restrictions the day you're flying. So those are really important things to look at. And also here in Arizona, the weather. You know, we don't have many snow days, but we have a lot of hot days. So make sure the weather parameters are okay for your aircraft as well. So each aircraft has specific weather limitations. So we have to make sure on that.
So Chuck, what you're telling me is drones don't like to fly in really hot weather or really windy weather?
No, they do not.
All right.
So, and all that. And then, also, the important time is when are you going to fly? Where's the sun when you're flying? So time of day is really important when you're flying these missions, so you don't get shadows. So, there's a lot to go into mission plan. It is the key to the successful project. Next slide, please.
Actually, Chuck, I'm going to keep you here for just 2 more seconds. That was really great. I want to flesh out a couple more things from you because you've got such great experience and you can give some wisdom to everybody. And everything you just said is so critical. Thank you for mentioning FAA and weather conditions. Could you talk to me a little bit about speed, altitude, and overlap? Any suggestions on what happens when the drone goes faster or slower, if it's higher or lower, and if you adjust, say, front and side overlap? Any thoughts on that?
Yes, I can try. My brain's a little dead after this long week, but definitely. Altitude is going to affect your ground sampling distance. So how big a pixel you want on your image. So you need to look at that for what are you doing as an end project. Overlap is probably, to me, the most important. Is that overlap just aids in that construction of a good 3D model. So by default, we use 75 or 80% of front and side overlap. Speed, it depends on your aircraft. A lot of multi-rotors will stop and hover and take the photo and then move on to the next waypoint. With a fixed wing, they keep flying. So, depending on the speed, if you're going too fast, the camera can't keep up. So, you have to look at that. And that's where weather comes into play, where, at one point you might be going with the wind and you might be going too fast and then going against the wind, you you're going to be slowing down quite a bit.
Oh,
Did that
that's
answer?
perfect. Yeah, no, that's great, Chuck. No, thank you so much. So let me move forward for you. Here we go.
Okay. So traditionally, in traditional orthophotography, most of them are nadir flights, looking straight down. It's great for coverage, getting a wide swath of ground. Like my fixed wing only does nadir, so it's great for creating topo maps of the natural conditions. Oblique is going to be at an angle, and maybe getting more of the sides, such as a building. Like we had a great topic just earlier with Jack Taylor here about culverts. Having an oblique photo might have helped in that situation. So it depends on the project and the terrain you're flying. You might want to use one or the other, or a combination of both. And Joe did a great job of supplying both on this project for Cave Creek Dam.
That's great. So fun fact, if anybody's just interested out there, Nader, and I may butcher this a little bit, but Nader was, I believe, a French guy back in like the 1800s who used balloons to start taking photography. He'd get up in a balloon and look down. It was sort of the first attempts at bird's eye mapping. So if you like history, there's a little bit of fun facts for you. And what I would say quickly about the oblique flights too, and like Chuck said, Joe used both, and so being able to use an oblique to say circumnavigate around an obtuse or weird looking structure like the dam helps fill in gaps where perhaps if you're flying directly over an object, if the object has an overhang or you're slightly off, you may miss some of that three-dimensional representation. So how about talking through a little bit again? Yeah, just a little bit more with this image here with the obliques and nadirs. Any other further thoughts?
Yeah, as you can see, we're looking at a man-made object, and getting those really sharp angles is very difficult with just nadir, looking straight down. So you're not getting all the features. Another thing that nadir will be involved in is shadows. What are you missing in the shadows? So if you can circle around and get more shots at different angles, will only help your model.
That's great. All right. So I was mentioning earlier a little bit about ground control and how ground control can make, three-dimensional data survey grade. Here on the screen, we've got on the left without ground control and one with ground control on the right. And I think you can see here very quickly that the option on the left, you can see the road is literally disjointed, where the option on the right, the road aligns a lot better. Have you just curious, Chuck, in your years of flying, any interesting stories about ground control or anything profound to speak about why ground control is important? Or maybe you've had a job where ground control got a little screwy and you saw something weird?
Oh, yeah. It happens all the time. Using like a DJI product, it has a pretty good GPS, flying in an area, using natural control or photo. I'm trying to think of the word. Sorry, guys. Identifying natural features to put in control if you don't have a chance to put in control before. It makes a pretty picture that there's no way to measure, no way to make distances, definitely not contours. So pretty much we use ground control on every project we fly. And then we also, on our fixed wing, we also use a PPK, post-process, using CORS base stations.
Oh, that's awesome. Okay. So for everybody out there, always use ground control. If you need or you have any other questions about ground control or any of these things for that matter, I've seen a couple questions come in. Kasey's logging the questions, and we would love to answer them at the end. You'll also see our emails at the end. If any of you would like to reach out to one of the panelists here specifically and talk to them more about, say, why ground control is important or what RTK is or core stations or whatever, please, we are here to help even after the event. So Chuck, I got another question for you. This whole idea of what structure from motion is, what is this all about?
So it is how we build the orthomosaic and how we build the point cloud in our post-processing software. So it's estimating the 3D structure from a set of 2D images. So it's all about the overlap. On this photo, this was all oblique images that the drone took, but there was that 70% overlap, and it's just trying to match features from one image to another and put it together and create a 3D model.
That's great. For all of you that are out there, hey Virgil, good to see you, sir. We were just talking about AZ cores, so your ears must have been burning. But if you're wondering what you're looking at in this image, obviously you see the building and the construction and such, but the halo going around the building, if you look at all the blue and green dots, what those are representations of where the drone was when it took the photo. And if you see the image, it's literally juxtapositioning the photo from the angle, kind of the distance and bearing. And so you can see it, in this picture, the representation of how the drone, like he said, obliqued and took oblique photos and went around the house target, shooting in on an angle. And that's what you're seeing here if you were wondering. This next image is a great example of what can happen if you do not do obliques, or you do not fly from multiple directions, or you don't get enough imagery. And you can see here, in this image, or in this example, it was flown from nadir, so top down, but it was only from east to west. And so what you can see are these gray splotches inside of the dam. And what that is basically a dead zone. It's where there was no imagery or not enough imagery, enough overlap there of images next to each other or overlapping on each other to actually create the three-dimensional data there. And then you can see conversely that if you fly north, south, east, and west, all of a sudden those gray splotches come in really, really well. Chuck, any thoughts on that? Anything profound to say?
Yeah, I think it goes back to that mission planning. You know the area you're going to fly and know what you want out of your flight. So it's kind of hard to plan some of these missions from just straight Google Earth. It's sometimes really helpful to get on the ground before you start planning these missions.
Yeah, absolutely. And in my experience too, crud in is crud out. Every time I've rushed a drone project, it's never worked out very well. You got to go slow. You got to be calm. You got to be composed. Follow those FAA regulations and rules about, having everything pre-planned. It makes me think about, I don't know, just again, another quick side tangent. I don't know if anybody saw this, but NASA landed and scooped up rocks off of an asteroid hurling through space. You don't think that NASA doesn't do, they are the epitome of mission planning. And I know a drone is maybe not a spacecraft flying out and scooping up rocks, but in the same essence, it is. You need to mission plan, understand the weather, understand the site. I love what Chuck said there. If the site was orientated differently, you potentially would change your flight patterns or your height, your altitude, your overlap. And the fastest thing that kills a budget and makes your boss really upset is having to go and fly the site twice, or wrecking your drone on the site and having to get it fixed. So knowing your site is just so critical.
Yeah,
Chuck, you
breaking
mentioned
your drone.
what?
Breaking a drone is not a fun way to study things. So
Yeah.
Don't train people. Yeah.
And all you out there who haven't crashed a drone yet, you will. So don't worry, it happens. So data processing software. Without being biased, I know you mentioned a couple softwares that Westland uses. But any comments about the different software or suggestions for the crowd out there?
No, I think the most important part, to me, the flying part is the easy part. It's that mission planning and the post-processing. And the the post-processing is the steepest learning curve. So, no matter what software you pick, it's going to take time for you to learn how to leverage the tools efficiently. So look at the options out there and kind of fit the program best fits for your workflow. If you're Esri shop, drone and map might be a good choice. Or if you're myself, we use Pix4D. We also add Virtual Surveyor because we're doing engineering, topo and contours. It just is a great tool for us. Bentley Context Capture, Agisoft. They all pretty much deliver the same product. It's just a slightly different for workflow.
Great. I got a question for you. So you want to get into drones, you go buy your drone, you flew it a couple times, you go buy the software. How many times would you recommend that you probably need to process a data set or fly a site before you feel confident enough to go bid on a job? Any thoughts on that? Like, how many times did you run Pix4D before you understood really what it was doing?
We were probably in it at least for 3 months before we started flying, asking for work. And that's in flying multiple outside our office. We have a empty lot and a wash. So we're flying out there, having our surveyors check it, and seeing how we're doing it. Do we fly east-west, north-south, learning those. So we were probably 3 months before we started working, getting paid to work.
That's great. Okay, so here are a couple examples of deliverables. Chuck, will you talk us through kind of what most of these software packages create? What are sort of the very standard deliverables drones produce for GIS and mapping clients?
So most of the time when you're looking at a drone, everyone sees the ortho photo, all the images processed and stitched together, so you get one image. But to create that, the software has to create a point cloud and a 3D mesh. So those are the standard 3 documents or with a digital surface model. Those are going to be your 4 standard products that most software gives you. The point cloud usually comes out as a LAS. Point cloud, similar to LiDAR, it's treated the same way in GIS software that you're not getting the classifications. The 3D mesh, like David Kirkpatrick at Global Mapper said it great. It's kind of the eye candy. It's taking that raster image and making a vector file out of it. And you can do a lot with it in 3D visualization. And then your orthophoto. So you're getting a really nice high resolution image that you can do a lot with.
That's great. Okay, so some of the other things that these softwares can produce, and they do produce, and we suggest that you utilize them, is reporting. One of the things that we discussed in this is you've got to qualify the data that you collect and produce, right? And it's certainly, if you're going to have a surveyor look at it or potentially stamp it or it be part of engineering drawings, you really have to qualify the fidelity of your data to make sure that it is in good shape. Here's some options on reporting. Chuck, in your processing experience, what are some of the things that you look for in a standard drone report to know that you either got good or, say, bad data?
Yeah, a lot of the software, they give you visual references, a red text or bold letters in these reports that kind of draw your attention to that. One of the first things we look at is the focal length on the camera. What is the software? How is the software adjusting the camera sensor to make it fit its model? You have a defined focal length on each camera, and the software is going to adjust that slightly to create its model. So that's one key things we look at is that focal length. How far did the software adjust that to make its model.
I got a question for you. One of the things I know that is produced is a GCP report. And I've noticed before that sometimes my GCP report shows that my deltas, my verticals, my offsets are very, very tight, very low. But sometimes I still like the data is not always so great. Can you talk to me a little bit about ground control, but blind ground control or test targets, or kind of the idea of beyond the report, checking with extra control? Any thoughts on that?
Yeah, definitely. So when we're doing our project for our engineering group, our surveyors will go set the ground control for us, and they will also do checkpoints for us. But they won't give us those checkpoints. And we run our process using the ground control given. And, we have tolerances depending on the product we're delivering. The surveyor will go through and check our surface and use those as checks on our work. And only when they feel comfortable they will accept our orthophoto and our contours. So having those checkpoints is really, really good and makes me more comfortable with the product I'm giving to the client. Having that outside check.
Yeah, it's like third-party insurance or something, right? Yeah,
Exactly.
and one thing I've noticed out there is be careful on your reports when you are processing your drone data. Your GCP report will show you the best accuracy in the entire data set, right? Like as you get away from said GCP, the data can get worse.
Exactly.
Talk to me a little bit about classification, Chuck.
Yeah,
Please.
When you classify, so we're getting a point cloud, and now we can run it through some GIS software or some ortho photography software that can classify it to bare earth, buildings, ground, vegetation. So if we're making contours, we want to get to bare earth. We want to only include pixels that are on the ground, not in bushes, not in cars, not on buildings, and so forth. So running through some of these classifications, I know Pix4D does it very well, and Context Capture, all of them do a great job. But, just learning to leverage those tools in the software is really important. Because that's the only way you can get true ground contours is if you get down to bare earth.
Makes sense. So speaking of contours, you can see some contours there as well. On the lower right-hand image, this is actually an image from Esri, and I believe I saw Rob from Tucson out there from Quiet Creek, and Rob had put together some extra analysis beyond sort of this standard drone analysis. Rob, I don't know if you're out there, if you're willing to just talk for 2 seconds about kind of some of the neat things you've done in Esri, what you're seeing in that lower right-hand image. Are you out there?
Yeah, I'm here. Can you hear me okay?
Yes, sir.
Hey, great. Thanks, Nick and Chuck. On that image down there, when we got this project as part of the fly-in, we looked at it a little bit differently. We kind of looked at it as let's have some fun with this. Let's turn this essentially surveying project into a remote sensing type of a project. So we used some techniques to convert the 3D model into what's called a normalized digital surface model, and that's where we get those blue lines from. Eventually, those blue lines, so those are linear features. Those aren't part of a raster, for instance. That's actually been converted to lines. And then you see what looks like some bare earth there, kind of following the road below the dam. We used a remote sensing technique to tease that out. We divided the red band by the blue band, and that gives you, especially in the desert Southwest, that gives you a really good idea of where some bare earth is. And then we use something called a green leaf index to find out where that that bright green vegetation is, and then we use the digital surface model or the digital elevation model that comes out of the whole process to create um, those contours that you see there. So that all of that you see is put together from maybe 4 or 5 different layers, stacked on top of each other. What GIS does really well, and you get a pretty good little map from the whole thing. Thanks.
Yeah, no, thank you, Rob. That's a great example of how, yes, you can do some of this processing in the drone software, but Esri itself has a ton of remote sensing tools that can be applied to these type of data. One other quick thing I want to just mention about contours before we get to the Q&A, kind of fun part of this presentation is, one of the things I've noticed over the years with contours, specifically with drone data, is because drone data, we collect so much of it, right? If you have a ground sampling distance of 1 inch and you're collecting 1 million points on the project and you have a point every inch, and you're trying to use a point every inch to create a contour file, sometimes you get these really jagged looking weird contours that the average engineer or mapping specialist is not going to understand cognitively. And so one thing I just want to throw out there is normally when surveyors go out and topo an area, they'll actually lay out a grid, like a 50-foot grid, and they will shoot ground shots at a 50-foot area. And then they're going to go out and they're going to tag built features and curb lines and dam structure and such. They take all of that and they put it into a CAD software to create a 3-dimensional model. So why do I bring all that up? Because if you want to create deliverables that compare and are able to be used instead of, say, a traditional surveying material, like you're going to go out and actually GPS it, you've got to think like a surveyor, right? And you need to use the process like a surveyor to recreate that type of data. And so it's kind of apples to apples. Because if you don't, you get these weird looking contours, you don't apply ground filters appropriately, you get bushes in there and all these different things. So just want to throw it out there that, again, going back to what Chuck said, it takes some time when you jump into this market to really become familiar with your hardware, the drone, the rules, the regulations, but then also the hardware, or I mean the software, how you're going to process it, how you're going to deliver it. Because if you're getting into AutoCAD, that's a lot different than, say, getting into Esri. Not one is better or worse. It's just different. So last but not least, I'm going to pass the mic over or back to Kasey. And Kasey's going to open it up for some question and answer. That's kind of the recap on what we reviewed. But this is an open forum where we'd love to answer your questions. We've got everybody that originally chatted. And so, Kasey, it's all you.
Yeah, I wanted to introduce the rest of the panelists and give a short bio on the rest of them. So we have Chelsea Scott. Chelsea is a research scientist at Arizona State University and works for Open Topography. She uses remote sensing data, including LiDAR, UAV, and INSAR to measure natural and anthropogenic changes to the Earth's landscape. And Robert, who you saw earlier, Robert Davis grew up in Salt Lake City. As a boy, he hiked and explored the Wasatch Mountains. There, he gained a love for mountains, wilderness, and the West. He graduated from the University of Utah with a degree in geography in 1983, accepted a commission in the Marines. Then he spent the next 25 years traveling the world. In 2008, he left the Marines to write, teach, and learn. Robert holds a MA in National Security and Strategic Studies from the Naval War College and a Master of Science in GIS Technology from the University of Arizona. In 2019, he graduated from Penn State's Remote Sending and Earth Observation Program. He is a private pilot as well as a remote pilot. He is certified by ASPRS as a mapping scientist. And then we have Virgil Cotson. Virgil is a survey manager at the Arizona Department of Transportation, but more importantly, is a ASU alumni. Virgil is
the most important thing, Kasey.
Yes, indeed. Virgil is a professional engineer and a land surveyor in training. So I don't know how that came out, but thank you, panelists. And we do have a question from our chat room. from Chris Bertrand. How difficult is it to apply for clearance through apps such as Drone, Zone, and the like? Much of the area we will be flying in the future is a 66/SFC zone. I think Robert probably would be best at answering that question.
Rob, I would love to hear your answer, Rob.
Yeah, well, just for everybody out there, I make it a point to I don't know, wax about the FAA and the regulations. I haven't seen those designations. I'm not sure what those are. Personally, I tend to fly where there are no restrictions, and that way I can avoid the various leaps that you have to jump through to do that. So I'm not very good at answering that because I'm not sure what those the 66 something about probably surface zone. I'm not sure what those are. Thanks.
Well, I think I'm not sure what those designations are. That the nice thing that's been improving is the LANC authorizations, the immediate authorizations when you're flying in restricted airspace or limited airspace. So LANC has been a big upgrade getting that authorization.
So, what is the most memorable moment using a UAV? This can be funny, scary, or tragic, or an amazing moment. Chuck, I would go to you automatically, but I want to hear from somebody else.
That's fine.
Okay, I'll go. I guess the most amazing thing that happened to us working with the UAV, we were in New Mexico in the deep the Rocky Mountains there, that part of the Rockies that dips down into New Mexico, and there was we always have somebody, even though it's not required by anything in the FAA, we always have somebody when we're doing an operation that isn't really doing anything with the op, and that person is there to protect the pilot from people wanting to know what's going on. And because it often happens, you'll be flying somewhere and then somebody will come up and go, "Hey, what you doing?" And, or it might be the border patrol, it might be the police, it might be somebody else. So you can't really stop flying to answer their questions. So we had somebody else designated to do that. And we were in the middle of nowhere, and out of the tree line comes this cowboy on a horse with a dog, and it looked like something out of a Louis L'Amour novel. And so the guy I had designated, went over there and started talking to the gentleman, and his job, and this will be my next job. I'm almost 60 now. I still have a couple more jobs in me, but this will be my next job. His job was to ride the range and just to make sure that everything was going smoothly with the cattle. So that's going to be my next job. Thanks.
Thank you. Okay. Here's another question for the panel. In your opinion, where do you see the UAV market going in the next 5, 10, and 15 years? And anyone can chime in on that one.
Maybe LiDAR use?
Definitely.
Yeah, I can jump in and build off that, Virgil. Yeah, I would agree with Virgil, and I think you're going to see more and more drones, right? I mean, soon we're going to have drone cars. You see them on, the internet. I think you're going to continue to see regulation evolve. I think that you're going to continue to have more integration of different peripheral sensors, kind of following Moore's law, twice as fast, twice as small. every few years. I could see LiDAR being much more affordable and easier to enter into the drone market, not just photogrammetry. I also would say I think you're going to see drones used for other things other than just basic mapping, more real-time data acquisition for construction sites. Obviously, I think you're going to start seeing delivery and shipping. I don't see personally, and I'd also, give it back to you, Virgil, and love to hear what, say, the ADOT thinks about drones, but I don't see drones slowing down. And quite frankly, it's one of the tools that I think any mapping company or organization should have in their tool belt. Virgil, what does ADOT and the DOT kind of think about drones? Just curious.
So ADOT does like the drones. The biggest kind of hurdle, I think, has been tied a little bit with Lance. Like if there's an accident scene, kind of quarantining other people from maybe getting drones into the area so that they can do their investigation. Maybe have lane closures maybe a little bit quicker. Not close the road down. I know I've seen a couple of accidents. The last couple of days I've been driving up and down I-17, going back and forth to work. I know that that's been a big push for ADOT. They don't want to have the lanes closed for too long. So I know that that's been something. They're tracking the construction as it's proceeding. So if there's disputes with quantities and stuff, they want to get those disputes resolved fairly quickly so that they can get back on track with working on the project and not fighting over quantities or money or some of the other stuff.
Very good. So, of course, there are a lot of options in terms of drones. Could someone talk about, what when would you use a fixed wing or a rotor or rotary style drone, or matching that drone for the job? If someone can kind of elaborate on that.
Yeah, so I've flown actually quadcopters and fixed wing quite a bit. I'm looking at so I work at ASU a lot in education. And so if I'm working with students interested in teaching them how to fly a drone, I'll often start with a Phantom 4 DJI drone because it's relatively easy to use and relatively inexpensive. And in terms of the work that I would do with that drone, certainly if I wanted to look at for example, a vertical cliff face, then I would prioritize using that drone. We used EB fixed wing drones a number of times, particularly when I want to survey an area fairly quickly, and they have differential GPS options that make doing ground control ground control and just georeferencing much easier than setting up, for example, individual ground control targets at a very close spacing.
We do have another question that to kind of go off that. What do you recommend when flying in a rough area that has more than 400 feet release?
So some of these EB drones will actually have a terrain following capability. So that can help. You still want to be careful that you actually have a high enough resolution digital elevation model that it can use to navigate the terrain carefully.
Yeah. Kasey, if I could just add a couple of things to Chelsea's excellent comments.
Yeah.
She's kind of hit the nail on the head, because you got to look at a variety of things. You got to look at things as far as the product that you're trying to to develop the area, how big it is, what the terrain's like, and all of that. And that's all what I would kind of say internal to the whole process. And from that, you'll be able to figure out which one that you should use. There's also other things. There's external things that you need to keep in mind. For instance, an area that I fly often, there's border patrol helicopters, and this is over an area that is sparsely populated, so helicopters can drop below 500 feet. And I'm flying between 350 to 400 feet. So there's an issue there, and we keep an eye out. The trouble is, if you're flying the fixed wing, it requires a landing like an airplane, at least the EB, which is what I fly and Chuck flies, and Chelsea now I learned flies as well. It requires a landing. So it's going to do a downwind, it's going to turn base, it's going to do all of that stuff. And it takes a couple of minutes for that thing to come in and land. So if a helicopter shows up, I've got to move pretty quickly. However, if it's a rotary, you can stop that thing midair and drop and take control of it and just drop it to the ground or very close to the ground to get out of the way of the helicopter. So there's other things to take into consideration other than the geography problem that we're trying to solve. Thanks.
Thank you both. Robert, I'm going to stay with you on this one. There's a lot of drone data out there, and with that, our old friend metadata pops up. Could you explain how having sound metadata into play with drone data, how that works, and could you just kind of touch upon what you should do or some of the best practices for having metadata for drone and UAV data?
Yeah, it's there is a metadata standard out there for orthomosaic data. And I don't know what it is off the top of my head. I can get that to everybody. But if you go through that thing, I think we've got it posted on the UAS website. If you go through that thing, you will quickly find, it asks you, for instance, what were the sun conditions? What was the sun elevation? And all of a sudden you're kind of confronted with, gee, that would be probably pretty good to know, considering that, the manual for photogrammetry requires that you be above 30 degrees. And, and Chuck alluded to this, that, if you're getting above 30 degrees in the summertime means it's hot, because you're looking at, you're looking at mid-morning, and it may be too hot to fly that EB, which is Swiss, so they're thinking of more of a cool environment. It tops out at 95 degrees, which many times is before you reach 30 degrees in some sun elevation. So there's all sorts of questions like that in that metadata that you're kind of required to fill in. Ground sampling distance, focal length, all of that stuff that you're required to fill in. And if you follow the metadata and figure out what you need to answer for the metadata, your data will be better, because you're trying to, you've all of a sudden realized that there are these kind of requirements out there that people are interested in, that will make your data better if you try to get those numbers better. So that's where metadata can kind of help you out on the whole process. Thanks.
Thank you. I think this next question, I guess, can go to Virgil. Virgil, I know you are. I want you to talk more about control and ground controlling and truthing. I know that in your job, in all of our flying, is very important. But could you elaborate on some of the things you do to ensure that you have sound ground controls?
Yeah. So Nick actually did a very good job, Nick and Chuck, earlier talking about using blind panels as well as surveyors' data to kind of proof the compilation that the computer is kind of telling you. Whether you're shooting a paint stripe out in the parking lot or a paint stripe in the road, or picking up some readily identifiable feature from the ground, like maybe a concrete pad, or putting a target out there that you're not necessarily given the computer to control your project. those are all really good ways to make sure that you're getting confidence in the data that you're collecting. And so you really do need to think about that. And we also go out in the field and take a look at the site conditions. I mean, which way are the prevailing winds blowing? Maybe we need to change from a north-south flight pattern to maybe an east-west based on, what the prevailing winds are doing. Do we want to use a fixed wing? Is it a large area? Is it a smaller area? Do we need to go underneath of a bridge? Is there maybe some barrier that's keeping us from going? Maybe it's restricted airspace. We know that the quadcopters are a little bit more, you can control them a little bit easier than the fixed wing. But I know we did a Vulcan mine site. It was a borrow pit, and there was water in the bottom of it. So for us, it was not as opportune to use the quadcopter, so we used the fixed wing to fly over the top of it. Do you want to tie it down to state plane coordinates? Do you want to put it on a local coordinate system? Those are all things that you kind of want to be thinking about when you're doing the project. And then like Nick and Chuck kind of mentioned earlier, as well as Robert, you need to make sure that you understand what it is that you're going to be delivering to your client. Is it going to be engineering related DTM file with DGN, the topo, the base mapping for a project? Or is it, hey, we just need to do inventory because state land department is looking to lease off some property to somebody, and all we're doing is inventorying what's out there, maybe where the closest power is, maybe where the water is coming from. So all of those things kind of come into play. And to get back to what Nick had made a question of earlier, how long should you be doing this before you start delivering product? We're still learning stuff today, and we've had our drone now for, I think it's close to 5 years. So you got to be open to, we call it embracing the red. So if you see something that doesn't look right, you probably want to investigate some time or effort into looking at it to figure out what it is. Maybe that uneasy feeling, maybe you're getting your GCP, the data is coming back and the numbers are skewed or they're not looking right. Take the time to look into it to figure out what's going on, because maybe it's a learning moment for you. Maybe you can fix or Kaizen your process, make it better. Making change for the better is what Kaizen is. Anyways, is that kind of answering the question, or do you need me to? Okay.
Yeah, that's perfect. That's perfect. Thank you. Well, we're about finished. I think I maybe have one question to go, and that's regarding safety. And anyone can jump in on this. What are some of the things you do to ensure that you are flying safe? Whether it be a standard protocol that you follow that everyone should follow, but what could anyone just kind of elaborate on their safety practices?
I think the biggest thing for us. Go ahead.
Go ahead.
I was just saying the big thing for us is communicating to the whole team that's involved in the operation, and anyone around should know what's happening and what is the plan. So clear communication to the whole group on the day of the flight is really important to us, and then also all the FAA regulations before you get in the field is it safe to fly. So a big thing for us is communication between the pilot, the visual observers, and everyone else involved.
Yeah, the FAA has a operational risk management matrix that we fill out every time we go out to fly, and it keeps us honest as far as our mitigation, in different areas and what we're trying to do. I'll echo Chuck's point there. That's very good, making sure everybody is informed on what's going on. Thanks.
Thank you. With that said, I'd like to thank all the panelists and all the participants, and If you have any other questions, feel free to email. The emails was up on the screen of the people involved in the presentation. There's also, they will have a video. You can access the video through the AGIC Symposium site if you want to review anything. And thank you, and enjoy the rest of your day.